All right, today's lesson is on the definition of similar triangles. Triangles are similar if they have the same shape, but can be different sizes. So, for example, we have the two right triangles. These two triangles could be similar. All right, in order for two triangles to be similar, they must satisfy two conditions. One, their corresponding angles must be congruent. And two, corresponding sides are all in the same proportion. For example, consider the triangles below. We know they're isosceles because we have two sides that have the same length. Let's say this is 60 degrees. And let's say the base angles here are 60. All right. Can these be similar? Well, first of all, the sides have to be in proportion. So I have 3 to 6. And by the way, the definition of isosceles triangles says that the base angles are the same, then that forces the other side to be the same length. So I know this has to be equilateral triangle. And this reduces to 1/2. And since all the sides are the same length, it's going to equal, the scale factor is going to be 1/2 all the way around. 60 degrees, if I were to add all three angles up, that's going to make that 180 degrees. Now if I add 60 plus 60 and subtract that from 180, that's going to give me 60. So that forces the third angle to be 60. So yes, this would be a similar triangle. However, you can have a situation where it's not. Let's say the base angles are different. Let's say I have 20 and 20. That still means that these two are the same, but that means it's going to be a different length here, which is not going to make it proportional to this side, because I'm going to have a scale factor of 3 to 6 for one side, which reduces to 1/2, but I'm going to have a different scale factor for the missing side here. So remember, the angles must correspond. Are these two triangles similar, and why? Well, in order to figure this out, we have to get a scale factor. So looking at the short side of this triangle, I have 3 to 9. That reduces to 1/3. And I'll check the other sides. Let's see, I have 4 to 12. That reduces to 1/3. But what about the last one? I have 5 to 15. That reduces to 1/3. And that really forces the angles to be congruent. We don't have any information on the angles there, but if all three sides are proportional, it's going to force the angles to be congruent angles, the corresponding angles to be congruent. So we'll say yes, because the sides are in proportion. Are these two triangles similar, and why? All right, now we know this is a right angle. And again, we want to set up the scale factor. So I look at the short side, I have 3. The short side here is 5. So my scale factor is 3 to 5. All right, let's look at the other leg. I have 4, 12. Well, 4 to 12 does not reduce to 3 to 5. I get 1/3 here. So since 1/3 does not equal 3/5, I know it's not in proportion. So they are not similar because the sides are not proportional. Are two isosceles triangles always similar? The answer would be no, because it depends on the angles. Right? The angles have to be, corresponding angles have to be the same. If this was equilateral, let's say this is 60 60, 60. And this is just 30, 30. 30 doesn't match with 60. Even though the two sides here are the same length, but the angles won't match up. Are two equilateral triangles always similar? The answer would be yes, because in an equilateral triangle, the angle has to be 60 degrees in every equilateral triangle. The sides may differ, but it's still going to be in proportion because all three sides are going to be the same. This could be 10, 10, 10, 2, and 2, and 2. But it's still going to reduce to the same scale factor, and corresponding angles are going to be congruent because all the angles are equal to 60 degrees. In conclusion, two triangles that have different shapes are always, sometimes, never similar. Two triangles that have different shapes are sometimes, because it depends if they satisfy that condition. You got to make sure that the angles, corresponding angles, are congruent, and definitely make sure that the sides are in proportion. Two triangles that have different corresponding angle measures are never similar. They have to have the same corresponding measures. Or this concludes our lesson for similar triangles.